Happy Thursday. Any questions before we get started here? And so, of course, do remember that we have presentations on Tuesday. Sorry. Need to map my poor tablet. All right, there we go. So, presentations on Tuesday. So, that's for our poster presentation. And so, again, right, if you need help with printing, ask me sooner rather than later, but I'm fine printing the day of. I understand that will probably happen. Otherwise, right, you can also just print out the separate components, so title, and then I'd probably separate it like your introduction, right, your meat, your conclusion, whatever else. You could print those on separate pages and paste those as well. I just ask that, like, don't do hand-drawn stuff because it probably won't look professional unless you're like an absolute professional artist or something like that. So don't recommend hand drawing anything. We want them to look at least somewhat professional. And then last week of lab this week, so aspirin synthesis, I think it went well for the Tuesday lab. And so it should be fun for the Thursday folks. And then makeup, so we can either do any makeups today if we need to squeeze those in. Otherwise, kind of, right, the last chance for labs will probably be next Thursday. I mean, if you beg me, I'm sure we can do something finals week, but trying to get stuff wrapped up so the stockroom also doesn't have to worry about our class anymore. So that's the goal, get it in. And like I said, if you can't do this, need other accommodations, and we'll try to work around it, but let's get those done. And then we will have our quiz today over last week's, a bit of transition metal chemistry. So let's continue with where we were. And so some of this is just kind of looking at these different reactions that they can do. We've seen, right, this is acetic acid, and it might be useful to write it out. Again, I would keep kind of practicing seeing this in your mind, that this CHOOH thing is our carboxylic acid group generally, right? That's what they're trying to at least go for, and not nachos or something. I don't know. I still always just think nachos when I look at these, or sodium acetate, I guess, looks like nachos. But anyways, right, just kind of seeing that in your mind, seeing the different representations, and then looking, again, we've seen this reaction, right? We did a titration, so this is just our acetic acid, and then reacting with our base. But again, we just want to think about this mechanistically. So then we have our hydroxide. And then it's going to come along. And again, arrow pushing. So action always comes from the electron. And so it should come and pluck off that hydrogen, like we've learned. And then we get our conjugate base salt, like we've studied. But again, just appreciating kind of the structure of it now. And of course, water. So this is, again, formally our neutralization reaction. But then we see, again, like we hinted at, that there's different bases that you can form in your reaction. So you would like form this base and then add something else to it for your base to be attacked. So it's a good reagent. And so with that, we could do the same thing with our making our formates or acetates, or also with like alcohols. So we could also do this deprotonation, so reacting like ethanol with sodium, which I think we looked at yesterday, but again, just kind of looking at it again, looking at the deprotonation. And so that's going to deprotonate this and make the ethoxide. And your counter ion is sodium, and then hydrogen gets released there. And so like we said, right, good reagents. All right, so back to our carboxylic acid. So then other types of reactions that we're going to look at are these condensation reactions now. Condensation reactions. And so this is, quick aside, we're kind of, like I said, we're barreling towards the end. We're looking at our last mechanisms. So in our lab today, we're looking at polymerization. And kind of the two main mechanisms is either your polymerization reactions are radical initiated. And so that's often what we see. That's kind of the reaction that we were looking at, like with ethylene. So if we were to look at those mechanisms right there, a radical initiated mechanism, and then termination is then when two radicals come together. But if it's not a radical, then the other polymerization, again, this isn't all-inclusive. But then we tend to have a lot of condensation reactions. And so we're going to continue looking at these condensation reactions next week as we also look at like amide bond formation. So that's kind of like a similar vein of our condensation reactions. And I think we've mentioned them before in the context of Le Chatelier's principle. And so condensation reactions produce water. And so we'll look at, again, how we can turn that into a polymerization reaction. But we can start to look at some of these mechanisms here. So taking, and I just kind of threw out these like standard acids that are often used in different reactions. But then looking, okay, so if we want to do a condensation reaction, this is going to be part of our leaving group. And so let's just add I'll just do R here for any generic, right, carboxylic acid. And then we can add it with an amine here. I'll just call this R2 for now. Again, kind of generic R. And then, okay, well, condensation reaction, we're trying to lose water. So again, this is going to leave. One of our H's is going to leave. And so then we produce water in these types of reactions. And then we'll make our new bond there. So H and then R. Or, you know, another organic group or something. And so that's, again, right, the idea of the reactions that can occur. So let's look at another, let's see where my notes are. There we go. Let's look at another common type of reaction. And so this is an esterification reaction. So are you guys familiar with esters at all? Anybody know like where you have probably encountered lots of esters probably without realizing it? Yeah, fruity flavors. And so I always think of like Laffy Taffy is kind of the synthetic example, and chat has it too. So yeah, fruit. And so now we'll kind of scroll down to this. But this is a common lab that you do in organic chemistry, is that usually they give you some sort of alcohol, some sort of carboxylic acid, and then you react them to make the ester as shown here. And then what's fun is there are all these different fruity flavors. And so depending on the OChem class, right, there's some sort of gig or however you want to call it, right, where you have your starting material NMR, you have your final product NMR, and then you have to figure out how you put your carboxylic acid together. So let's kind of look at that and see who goes where. So just kind of looking at our formation. So we want to just see like, okay, where is our alcohol? And then where is that adding to? And so if we look at, right, our mechanism, so let's just look at some more examples. So we start, and let's do our carboxylic acid here. And I'll pick a 1, 2, 3, 4. So okay, we have our 4-carbon chain carboxylic acid. And then let's go ahead and add it with ethanol. And so here's part of, right, the again the puzzle. Sorry, words are eluding me. And okay, so again, we're seeing who's leaving, and so that means that this OH again is going to leave. This hydrogen is going to leave, and then we're going to have our new bond formed between, right, this carbon and this oxygen here. So I think that formally mechanistically, right, this oxygen probably attacks here, and then this would cause water to leave. We don't need to necessarily go through the reaction mechanism, but again, we can just see, okay, our alcohol is what's attaching. So then we just want to be able to identify, okay, so now when I rewrite this, right, kind of this part was from our